We're now going to solve, we're going to use substitution with a 3-variable system.
This is on a new page?
This isn't, yeah, I would, because that was review, I would start a new page with this one. But so these are our 3 equations, because if you have 3 variables, you need 3 equations. Step 1 is choose any equation and solve for one variable. Now, just for convenience sake, I'm going to label these equations so that we can keep track of where we are. So I'm going to call this one equation 1, this one equation 2, and this one equation 3. If we look at that group, equation 2 is already solved for S. So we already have that. So we're going to choose equation 2 because it's already solved for S. Step 2, substitute for the variable in either of the other equations. So, do you want to substitute in 1 or in 3 first? It doesn't matter. I don't see anything that's going to make 1 any easier than 3, and we have to do both of them, so let's just do 1. All right? So we're going to substitute for S in equation 1. So my equation is 4R minus 4, and in place of the S, I'm going to put all of this right here, because S is equal to all of that, right? So 5 plus 2t minus 4R So I substituted what S was equal to into equation 1, and I've written it out here. Now we just do the algebra. We distribute the negative 4 and we combine all the like terms. The 4R is still here. Negative 4 times 5 is negative 20. Negative 4 times 2t is negative 8t. Negative 4 times negative 4r is plus 16r. Plus the 4t that was still there is equal to negative 4. We're going to add the 20 to the other side. And then we have 4r. We have 4r plus 16r. So that is 20R. Chose the wrong color. And then we have negative 8t plus 4t. Which gives us negative 4t. And negative 4 plus 20 is 16. And I'm going to call this equation 4. Is my math okay? Everybody follow through with that? Right. Step 3 is to substitute for the variable in the remaining equation, the one we haven't used yet. Be sure it's the one you haven't used yet. So for us, that is equation 3. So we're going to substitute for S in equation 3. So we started with equation 2. We used that to substitute in equation 1. Now we use that, the same thing from equation 2, to substitute into equation 3. So equation 3 is negative 3r minus 3s. So instead of s, we put 5 plus 2t minus 4r. So that was minus 3s. Then we have minus 4t equals negative 16. Distribute the negative 3, so we have the negative 3r here. Negative 3 times 5 is negative 15. Negative 3 times 2t is negative 6t. Negative 3 times negative 4r is plus 12r. The minus 4t is still there, and the negative 16 is still after the equal sign. So we're going to add the 15. So we have a negative 3r plus 12r. So that's 9r. And then we have a negative 6t and a negative 4t. So that is negative 10t. And negative 16 plus 15 is negative 1. And we're going to call this equation 5. Anybody not have this yet? Still copying? Anybody still copying? Everybody have this one? So I'm going to go to a new slide, but I'm going to copy part of this over. Come on. Paste. So let me erase the part I don't need. And then whoa, what is that doing? Okay, so we have our equation 4 and our equation 5. I don't know what that business is. So this is our equation 4 and 5. And now we have to repeat the process. So we're going to solve one of these. That 9 and 10 is going to give us a fraction, but everything in the top one is divisible by 4, so at least the fractions that we get will be nice normal numbers. Do you want to solve for R or T? Oh.
Q.
Yeah, we'll do Q. So, okay, we'll solve equation 4 for T. So we have 20R minus 4T equals 16. We subtract the 20R. So we have negative 4T equals negative 20R plus 16. We divide by the negative 4. That was a good choice. We don't have any fractions. So T is equal to 5R minus 4. So this is our step 4. Repeat, solve, and substitute. So now we know this is what T is, so we're going to put that into equation 5. So we take equation 5, which is 9R. This is equation 5. Minus 10T, but instead of T, we put the 5R minus 4. And that's equal to negative 1. So we're substituting for T. So we solved, what we did is we solved equation 4 for T. And then we substitute for T in equation 5. So now we just do the algebra. We have 9R. Distribute the negative 10, so we get negative 50R plus 40 equals negative 1. So 9R minus 50R is negative 41R. And we subtract 40 on both sides, so that's equal to negative 41. So R is equal to 1. So now we know R. we're going to put the value of r in either equation 4 or 5. So this is the step 5. Substitute value. You can't read that. Into either 4 or 5. Do you have a preference? Five. So we're going to use 5. We say 9 times 1 minus 10 times t is equal to -1. So 9 times 1 is 9, so we're going to subtract 9 from both sides. So -10t is equal to -10. And I'm out of room. I'll put it here. T is equal to 1. T is equal to 1. That's a little messy. Are you ready for the last step? Okay. So we know that r is 1 and t is 1. So we know r is equal to 1 and t is equal to 1. So now we can go back to any one of the 3 original equations. I think I would use the middle one. S is equal to 5 plus 2t minus 4r, since we know t and r. So if we go back to the original equation 2, which was S equals 5 plus 2t minus 4r. And then we substitute in the values. S is equal to 5 plus 2 times 1 minus 4 times 1. So 5 plus 2 is 7, minus 4 is 3. So our final answer, okay, if we had x's, y's, and z's, we would know that x, y, z is always written in order, x, y, and z. For this one, r, s, and t, I'm going to go by the order of the equations, and in the equations it's r, s, and t. So our final solution is 1, 3, 1. So this is r, s, and t. So what we have is 3 lines, and they have intersected in one point. So you have to think about this as 3-dimensional. I don't know if I can draw it. Let me see if there's a picture in your book and I can show you. Wasn't that fun? That was one problem. Okay, yeah, here's a good picture.
That was nice. I was relieving. I don't know why.
So,
I know.
check back around. It's where you have three pieces of paper, but they're only intersecting in that one point. If you ever did that thing where you cut a slit in one piece of paper and cut a slit in the other, and you slide them together so that you have the three pieces, that's what this is. We just solved the system. We found the one point where all three of these planes touch and intersect. Another option is that all three of them intersect, but they intersect as a line here. So like those pinwheel kind of things. A sheet here, a sheet here, and a sheet here, and the only place they're touching is here, but they're touching all along this whole line. So sometimes you get a solution that is infinitely many because it's all along that line. So those are two possibilities for getting a solution to a system of three variables. If you get any of these three, these three on the bottom, if you have any of those situations, there is no solution because there is no place where all three are at the same point. They don't share the same space anywhere. This one, these two intersect, and those two intersect, but there's no place where all three of them intersect. This one, two of them are parallel, intersected by the third one, but they don't all come together anywhere. And in this situation, all three of them are parallel and none of them will ever intersect. But to all three of those, there is no solution. So we'll need to look at some where you have a no solution answer so I can show you how that works. And we'll need to look at least one where you get a line for your solution instead of the single point like the one we just did. So today we learned probably the most difficult way. Better to do that first, right? Don't start with there are easier ways to solve this. Next class.